Okay, before we go into more subnetting, okay, I'm going to talk about how subnet mask is used in determine two very important address when we look at IP addresses on host devices or of any devices. Okay, I'm going to talk about a very simple example regarding our addresses that we can see, especially most of us in Singapore. Okay, we stay in a HDB flat or in unit that have many floors. Okay, take for example, okay, a number such as this. Okay, okay. So by young we have been taught that how to actually interpret addresses in the form of this. So we know that anything after the hex sign signifies the level. Okay, so in this case we are looking at level 15, and anything after the dash basically represent the unit. Okay, and okay, if I have another address such as hash 15-105, it means that this unit 105 basically will be on the same level as 15. Okay, so this is typical of an address that we can see in Singapore. Okay, and why do I need to mention about this? It's because of the usage of subnet mask in determine two very important addresses when we are working with IP addresses of a host. Because in electronic devices or on switches and router, they are just dumb devices that doesn't know how to actually interpret which portion of the address will actually determines the grouping, or in the networking world we call it subnet, that the address belongs to. Like for example, we know that by this address 105 and 103 is on the same level 15 is like in the same group of 15. So basically subnet mask will allow us to determine the network address of the host IP addresses, which will give rise to the grouping. And this is very important because in the networking world, we are not talking about the whole world is connected in one big group. Okay, if the whole world is connected in one big group, it will means that everyone is able to send data, transmit and receive, and there will be a lot of collision. Okay, so in actual fact that all the network in this world are actually split into smaller group, whereby if data need to actually goes from one group to another group, which in this case go from one subnet to another subnet, basically the usage of router will actually facilitate the data transfer from one subnet to another subnet, or from one group to another group. Okay, and basically this will bring us back to the topic of using subnet mask to determine some very special addresses in every group or in every subnet of addresses. Okay, so I'm going to make use of this Excel sheet to actually talks about making use of subnet mask to get two very important address. One is the network address and one is the broadcast address. So the short form NW, I'm going to actually reference it to network address, and BC basically I'm going to reference it to broadcast address. Okay, and these two are very special address because the network address is like the level that I'm referring to in the analogy that I've given just now. So that means that every addresses that have the same network addresses, that means that it belongs to the same subnet or the same grouping. Okay, and the broadcast address is very special address in the group that because when a devices within that group needs to actually send a message to everyone, it can actually just send a message to the broadcast address, which every devices in the same subnet or the same group will actually be listening out for. Okay, okay, and that is to mean that the network address and broadcast address are special address that can never be assigned to any devices, because it's for special usage. Okay, so before we can actually start to work to calculate the network address and the broadcast address, I've given here an example whereby most of the time when you're working with IP addresses on the devices, you will know that you also need to configure the subnet mask. Okay, so in this example here, I have actually been given IP addresses on a devices such as PC that having an address of 192.168.45.37, and the subnet mask that is being given is 255 192.255.255.224. And with this root address, okay, how can I actually derive, okay, the network address and the broadcast address? Before I can do that, okay, the minimum requirement, okay, is basically to convert these two decimal total notation to its binary form, okay, because, okay, we can only get the network address and broadcast address when we are working with the numbers in binary form. So basically, I have already converted the decimal number 192 into its binary form 11000000. Okay, based on, okay, these 8 values, okay, 128, 64, 32, 16, 8, 4, 2, 1. Okay, similarly, this is 168, 45, and 37. Okay, and 255 is, okay, a number that have all binary bits of 1. Okay, only the last number 2 to 4 basically will be having 1110000, because 128 plus 64 plus 32 will give me a 224. Okay, so the first address that we're going to calculate, okay, which is the network address, which is also the first address of the group or the subnet. Okay, and how do we get an address, network address? Basically, it's a very simple process. Okay, by basically doing a ANDing operation between the IP addresses and the subnet mask. And what is ANDing? Okay, basically ANDing is meaning I actually look at the bit, okay, bit by bit, and basically I do a ANDing operation. It's quite similar to multiplication. Basically, it's just, okay, multiplication we are talking about whole the number itself multiplied by number, but in ANDing we are talking about multiplication at the bit level. Okay, so basically, if you look at the truth table for my ANDing operation, okay, when I have bit 0 and 0, the output will be 0. Okay, 0 and 1, the output will be 0. 1 and 0, the output will be 0, and 1 and 1 will be 1. Okay, so it's actually quite similar to multiplication, but it's just that we are doing it at a bit level. Okay, so basically by doing a bit level, 1 and 1, I'll be getting 1. 1 and 1, I'll be getting 1. So basically, you'll be actually continuing with this process for every bit, okay, until 32 bit is been done, okay. And by the time when you get into the last bit, okay, this whole binary bit value, okay, will be your, okay, binary representation of the network address. Okay, and by doing a conversion from binary back to its decimal, okay, which in this case will give me 192.168.45.32. Okay, basically this will be my network address. Okay, this will be my network address. Okay, after I convert the binary to its decimal. Okay, okay, and how do I get my broadcast address? For broadcast address is a bit more involve a bit more step, okay, because for broadcast address, okay, I will need to make use of the subnet mask. Okay, and by now you should see that I have this red line here, okay, which help us to identify when we look at the subnet mask. The subnet mask is a sequence of 1 followed by 0. Okay, so a subnet mask will never have any sequence of 1 in between, there will be 0, or any sequence of 0 in between, there will be 1. You will always start with a sequence of 1 and end off with a sequence of 0. Okay, and all the 1, okay, and we look at subnet mask, all the binary bit 1 actually represent the network bit. Okay, is like, okay, the level analogy that, okay, we are looking at when we're comparing the address. It means that for every address within the subnet mask or within the grouping, okay, okay, the basically all the bit that corresponding to the 1 in this case will be, okay, 24, 25, 26, 24, 25, 26, 27, 27 bits. Okay, the first 27 bit will always have the same binary value. Okay, and all the different devices in the same subnet, okay, only the last 5 bit, okay, which is the host bit, will actually change, okay, to determine all the different IP addresses in the same group. Okay, so by understand this concept, we will actually be able to draw a line, okay, that actually split between the binary 1 and the binary 0, okay. And by drawing this line, okay, the next step is to look at your network address, okay, all the bits that comes before the red line, okay. Basically you just copy it down, okay, because as I mentioned, all the addresses within the same subnet, okay, the first 27 bit must have the same binary bits value, okay. And after the line, okay, you can see that for the network address, all the binary bits are 0. So for broadcast address, okay, change all the bit to be 1 or invert all the bit to become 1. And basically this will give you, okay, the broadcast address. So basically do the necessary binary to decimal conversion, okay, and you'll be getting your broadcast address to be 192.168.45.63, okay. And when we make use of this method to actually determine the network address and broadcast address, and we also must also know that the network address is always the first address of the subnet, and the broadcast address is always the last address of the subnet. So by knowing this, we know that, okay, basically when we look at the range of IP addresses within the group, okay, it will be from 192.168.45.32 all the way until 192.168.45.63, okay. And but we know that network address and broadcast address are special address that cannot be assigned to any devices. So it means that, okay, I can only use the numbers between 32 and 63. So when network address plus 1, I'll be getting 33. And when broadcast address minus 1, I'll be getting 62. So that means that within the subnet, I can actually assign any devices within the subnet to have an address, okay, from 33 all the way to 62, okay. And how to, no doubt that we are working with very small number here, but if we are working very big number, cannot be I actually count the number of address to determine the total address or the total IP addresses. So basically, a very shortcut formula to use to determine the number of addresses within the subnet, okay, or the total usable IP address to that have within the subnet will be actually making use of the formula 2 to the power of host bit, okay. So basically, I know that, okay, by referring to the subnet mask, I know that I have 50, which means that I have 5 host bit, okay, 5 host bit. That is the reason why I have 2 to the power of 5, which gives me 32 address. So if you were to manually count the number of addresses between 32 to 63, you will be getting 32 IP addresses, okay, when we look at the 5 bit of 0, okay. And since we know that the network address and broadcast address cannot be used, that's the reason when we calculate the total usable IP addresses, it will be 2 to the power of host bit minus 2, which is to minus the network address and the broadcast address. And basically it will give me 30 address. So that means that from 33 to 62, if I go to manually count it, it will give me 30 address. Okay. So by explaining this, let's do another example to further reinforce, okay, what we understand from this. So given the IP addresses and the subnet mask for host devices, okay, let's actually first step, let's convert this to its binary representation. Okay, so 10 will be 0, 0, 0, 0, 1, 0, 1, 0. Okay, and 20 basically will be 0. I cannot minus 128 from 20. 64, 32. I can minus 16 from 20, so it will be 1, 0, 1, 0, 0. Okay. Okay, so for 20 will be 0, 0, 1, 0, 1, 0, 0. Okay, for 30 will be 0, sorry, 0, 0, 0. Okay, I can minus 16, so I'll be left with 14. I can minus 8. 8 will be left with 6. Okay, so this will be my binary representation of decimal value 30. Okay, and for 40 will be 0, 0, 1, 0, 1, 0, 0, 0. Okay, so this will be my binary representation of 10.20.30.40. Okay, subnet mask 255 will be all 1. Okay, so the third octave is 192, so I need to actually, sorry. Okay, I can minus the 128 from 192, so I have 1. Okay, I can minus, after that I will be getting a remainder of 64, so it will be 1 again. So the rest will be all 0, 0, 0, 0, 0, 0, 0, 0. Okay, so 128 plus 64 will be 192. Yes, correct. So I'll be having my IP addresses and the subnet mask. Okay, and we know that by looking at the subnet mask, okay, by looking at the line that splits between the 1 and 0, okay, the 1 will actually correspond to the network bit and the 0 will actually correspond to the host bit. Okay, so I'm going to actually merge this and I'm going to merge this. Okay, I'm going to write there network bit and I'm going to write there host bit. Okay, so the next step is to determine the network address, by doing a ANDing operation. IP addresses end with subnet mask. I'll be getting my first address of the group subnet will be my network address. So by doing ANDing, 0 and 1 will be 0, 0, 0, 0, 1, 0, 1, 0, 0, 0, 0, 1, 0, 1, 0, 0, and 0, 0, 0, 0, 0, 0, 0, and 0, 0, 0, 0, 0, 0, 0. Okay, so basically this will be my network address, which will be the first address of the subnet. Convert this back to its decimal dotted notation. Basically will be 10.20 dot 0 dot 0. As we can see from here. So basically, the next step is to determine a broadcast address. So if you still remember anything, when we look at the line that splits between the network bit and the host bit, basically look at the network address, whatever value that you have before the line, just copy it down. And everything after the line, change the bit to become 1. And basically this will give me my broadcast address. Broadcast address. So basically to get the broadcast address is very simple. After you get your network address, make sure you identify the line that splits between the network bit and the host bit. And basically copy whatever bit that you have before the line down. And then you invert all the bit that you have for the host bit to be 1, and this will actually give you your broadcast address. So convert this back to its decimal dotted notation. So this one will be 63. 63 and 255. Yeah, 63, 63, 64, 17, 28. Yeah, correct, 63. So my first address of this subnet will be 10.20.0.0, and the last address, which is the broadcast address, will be 10.20.63.255. After I do the ending operation and do the necessary working to get the broadcast address. So for range of address, it means that my address will actually starting from the top octave, it actually changes. We'll start from 0.0, okay, all the way to 63.255. Okay, and for the range of usable address will be 0.1 because plus 1 all the way to 63.254. Okay, so it's a very big number because I'm using for the example, okay, the subnet mask actually give me a very big group of addresses to be used. Okay, so to calculate, okay, your total addresses would be 2 to the power of how many host bit in this case? Okay, so let's do a counting. Okay, 1, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's 14. Okay, so basically 2 to the power of 14. Okay, okay, 2 power of 14. Okay, so if you use a calculator to calculate 2 power of 14, 2 to the power of 14 will give me 16,384. 16384. Okay, and to get the total usable address after subtracting the first address, which is the network address, and the last address, which is the broadcast address, 2 to the power of 14 and minus 2, okay, I'll be getting 16382. Okay, so basically this is how you can actually derive the network address, the broadcast address, the range of IP addresses, the range of usable IP addresses, the total IP addresses, and the total usable IP addresses.